All right, in these notes we're going to be learning about the transformations of absolute value graphs. So the very first thing I want us to do is just look at a regular absolute value function. So we're going to grab our calculators if you have one at home. If not, that's fine. And the way that you graph an absolute value function is we're going to go into the y equals screen. And to get to the absolute value function, you have to hit the math button right here. And you have to go over to number type. And ABS stands for absolute value, ABS. And then it'll look like that if you have a newer calculator. If you have an older calculator, it'll actually say ABS and put the parentheses there. And then I'm just going to type in this X right here, absolute value of X. And then I can hit the graph button. So if you started off with a graph that had nothing in the memory changing it, no window changing it, things like that, then it will look like a perfect V graph like this. And if I want to get the values from the table, then I'll go ahead and I'll hit second graph to get the table, the blue, so second graph. And I'm going to scroll up using the up arrow. So -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. And the point right in the middle is the vertex. And so when I graph these, I always want to find the vertex and then 2 points to the left and 2 points to the right. About 5 points is going to be perfect for us to make sure we can always graph and see enough information. So this was a very simple absolute value graph. It didn't have any transformations. So I do want to talk about the transformations. This is what an absolute value graph looks like with the transformations. We have A multiplied by the absolute value of x minus h plus k. And so I want to talk briefly about what each of those transformations are. So I'm going to show you Desmos on my phone. So here, hopefully the glare is not too bad. Here is Desmos on my phone, and you can see just the regular graph right there. Okay, and so we want to figure out in this equation what the A, the H, and the K do. So I'm going to look down here. I have all of these, the A, the H, and the K as sliders. So I'm just going to show you the A values can take the graph, they can make it get wider, they can make the graph get skinnier, and they can make the graph flip upside down. So that's kind of the interesting thing about the A value. So if we look, values that are negative will make the graph upside down. It doesn't matter if the values are decimals, and you can see that the decimal values make the graph wide. So these small decimal numbers, they make the graph really wide. So the size of the number being small makes for a short graph that's really wide. If it's negative, it's going to be upside down. If it's positive, it's going to be right side up. So I'm going to say if the A value is negative, we have that the graph is reflected over the x-axis. All right. And then if the size of A is small, so we're going to think about fractions like 1/3, 1/2, small decimals, 0.3, 0.7, things like that. So if the A value is smaller than 1, and right here I'm not talking about negative versus positive, I'm just talking about the size of the number. If the size of the number is small, then the graph is vertically compressed. That's what we call it when a graph has been made very short and fat kind of looking. We would say vertically compressed. And then if you get numbers that are bigger than 1, so 1 is actually a perfectly normal graph. No transformations to the height or the width there. That's just normal. And then as soon as we get over 1, you can see that the graph is going to get really, really skinny. So really tall, really skinny. Same thing on the negative side. get those bigger numbers, we get a really skinny graph. So again, the negative, all it does is it reflects it upside down, but the bigger numbers make it tall and skinny. So if A is greater than 1, we're going to say that that graph is vertically stretched. Okay? Next, let's go ahead and we'll put this A back to that normal. I'll make it 1, just like normal. Okay. Put this back in the middle, and now let's see what the H does. So that H value takes the graph and it moves the graph from left to right. Okay, so we've got left and right. Okay, and then we have the K value, which you can see, this K value moves the graph up and down. Takes the graph, it moves it up and down. Okay, so what I want to show you guys is what specific numbers could do. So let's say that we have the absolute value of x minus 2 and then plus 3. You can see that the graph has been shifted to the right 2, and it's been shifted up 3, and you'll be able to tell that because I'll show you what a regular graph is. So here the blue, I don't know if you can see the two different colors, but this is the regular graph, and the other graph that I did had been shifted to the right 2 and up 3. So if you have a minus inside, it actually does the opposite of what we would think. A minus inside actually shifts you to the right. So a negative shifts, oops, I mismarked it. A negative shifts you to the right. Okay, so if there's a negative inside the absolute value sign, that's going to shift it to the right. And then the graph was shifted up 3, and that was because there was a plus 3 outside. We had a plus 3 outside, and so it shifted it up 3. So plus outside the absolute value. Now I could go ahead and I could take that plus 3, make it a minus 1, and then that graph is still shifted to the right 2, but now it's been shifted down 1. Okay, let me go ahead. So I took off the shift at the end, so now it's not shifted up or down, but it's only shifted to the right 2. Let me change that on the inside, and I'll change this to a plus 2. Now it's been shifted to the left. So a plus on the inside will shift it to the left. All right, and a minus on the outside will shift it down. So these transformations are things that we're going to memorize. We are not just doing them for absolute value. We're actually going to do them for all of the different graphs that we're going to be studying. So don't feel like I just told you something really crazy and we're going to learn something else right away. We're actually going to do this over and over and over again. Now, one thing that's also interesting here, I'll go ahead and put that same example that I had back, plus 3, is that you can actually find the vertex from the equation. So here I had 2 and 3, and if I click on this to know what the vertex is positive 2, positive 3. So the vertex is the opposite of this number and exactly the same as this number. So it's the opposite of what's inside the absolute value sign, and it's exactly what's on the end. And to me, that makes sense because the left and the right are kind of the opposites of what I would think. So a plus number means that it's moving to the left, and a minus number means it's moving to the right, which to me feels backwards. So the same is true with the numbers. If it says minus 2, it's actually positive 2. And then plus 3 kind of makes sense. And on the outside, those kind of make sense. Plus means it moves up, minus means it moves down. down. So the vertex, if we look up here at our formula, it says minus h, and so the vertex is actually positive h. And then k, because it just says k. So let's go ahead and let's look at an actual problem to see what I would expect you guys to do with this. So here, with the examples, with the things that we would be practicing, we would be finding the transformations, we would be finding the vertex, and then we would be using a calculator to graph. So I'm going to go ahead and find the transformations. I have a 2 in the front. A 2 is positive, so it's not negative, so I'm not going to look at this. A 2 is bigger than 1, so that's a vertical stretch. So I'm going to say the 2 is a vertical stretch. Well, I guess you can write it out. Vertical stretch. And then inside, I have a minus on the inside, and so that means that it's moving to the right. It's moving to the right 3. And then I have a minus on the outside, and so that means it's moving down 1. Okay, and then next I'm going to go ahead and write down what my vertex is. It's the opposite of this number and exactly the same as this number. So the opposite of negative 3 is positive 3. The same as negative 1 is just negative 1. So now I have my vertex. So I'm going to go ahead and grab my calculator so I can graph this. And I will clear this out. So I'm going to start by typing the 2. And then I can hit the math button and go over to number and start with ABS. And then inside I want to type x minus 3. And then that's the rest, that's all that was inside the absolute value, so now I want to get out of it. So I'm going to go over, and on the end I had a minus 1. So now I have all that stuff. I'm going to go ahead and hit graph. So there is my picture, and so now what I'm going to do is look at the table so I can get some points to graph to make this easier. So second graph. And the point that I'm going to look for is the vertex, 3, negative 1. And when I get there, I want that point, and then I want 2 points above it and 2 points below it. So I always just want to get 5 points. So 3, negative 1 is the vertex, over 3, down 1. And then 2 points on one side. So 4, positive 1, 5, positive 3. And then 2 points on the other side. 2, positive 1, and 1, positive 3. And then that is my graph. All right, we'll have that be the end of the homework video. Tomorrow in class, we will finish taking the notes.